All right. So we're going to do something a little different today. What was looking at the schedule, we're going to be having an exam. We need to have an exam soon. And the reason is we covered chapter 0, we covered chapter 1. We made some big leaps in chapter 2. We were able to cover a couple sections at least in one day. So what we want to look at now is, before the information from chapter 0 and chapter 1 starts to get a little stale, we want to get into reviewing for the test. We want to review for the test on those two chapters, chapter 0 and chapter 1. And so what we're going to do, I'm going to review today. I'm going to go over material that's from the chapter 0 and chapter 1. Mostly chapter 0 we'll do in the lecture session, and then we'll take a break. And then in the lab section, we're going to do chapter 1. And I just want to talk about the test a little bit. So first off, test prep. The best advice, and probably the most common advice you're going to hear about preparing for a math test, is to practice, practice, practice. Get confident with these problems. Mathematics is sort of like learning to do gymnastics. If you watch somebody do it, okay, you kind of see what they're doing, but then you try it yourself and you realize, oh wow, this is very different from what I thought. So you want to practice until it becomes comfortable. The other thing I want to mention, well, let me tell you a story. I had an exam, a final exam I needed to take for a differential equations class. And what I did is I listed the problems that I thought were most difficult for me, or problems I knew I needed to practice. And then even some that were just difficult, but when I was doing the homework, it wasn't a problem. But maybe if I'm under the pressure of a test, it might be kind of tricky. So I listed these problems down, and I did each problem 3 or 4 times. I spent I must have spent something like 5 hours almost continuously working on these problems, literally to get up only to get like a drink of water, a very quick snack from, say, like a vending machine, or maybe to use the restroom. And then that was it, the whole time just working on these problems. And it just built confidence. And so I did well on the test when I took it. And I think that's what made the difference. The other thing, I would mention is, when you're taking the test, do the easy problems first. The mistake you don't want to get into is something like this. On these tests that you're going to take, what we're going to do is we'll take the test online through XYZ homework. And the problems are random. So there's no algorithm that says give the easy problems first and the hard problems last. They're all going to be mixed up. And sometimes easy and hard is kind of relative. What might be easy for someone might be hard for you. What's easy for you is hard for somebody else. You might get into a situation where, out of a 20-question test, you do the first problem. By coincidence, it turns out to be easy. But the next 3 problems are the hard ones. And you spend a ton of time trying different approaches, and that just gets you through the first one, and you still don't get it right. Ah, geez. Because on the test, you'll have like maybe 3 attempts, and that's it. So you go to the next problem, problem number 3. So 1 was easy, 2 has been, oh gosh, 2 didn't work out. Go to problem 3. Again, you burn up a lot of time, say 15 minutes working on it, just like you did on problem 2, and you still get it wrong. And then you go to problem number 4. Same thing, put 15 minutes into this thing. Could be some crazy story problem or something. And then you still don't get it right. So let's say you spend 10 minutes on each of these problems. You're really determined to get them right. So that means with maybe the 1 minute you spend on the first problem, not even that, I don't even worry about it. You spent 30 minutes to get 3 problems, unfortunately, wrong. Sometimes that happens. and you still have 16 problems to go. And only one of them you've gotten right so far. But you've taken up 30 minutes of time. That means there's only going to be 45 minutes left. So 30 is gone, you have 45 minutes left for the rest of the test. But if you do the easy problems first, in that first 30 minutes, you might have half the test done. So it gives you a lot of confidence, you're feeling good about yourself, and then slowly you move into the harder problems. So what I recommend doing is this. Do the easy problems first. Then do kind of the moderate problems. Save the hard problems for last. Now there's different arguments you can have for or against this approach. You could say, well, if I save the hard problems for last, I'm going to be maybe a little more tired and I might not do as well on those. But you can also argue that you're warmed up. You've been doing the math, and suddenly a lot of those sort of tricks you used in the homeworks, they're all alive now. You're remembering a lot of things, and so you're ready to take on these harder problems. So I recommend easy problems, then medium problems, and then hard problems. The last thing, I'm just going to mention it. When I was in college, I have to admit, I studied for a lot of my tests the night before. If you can, especially if you have work on, say, Sunday, because we're going to do the test on Monday, try to start as much as you can. Try to start studying. What we're going to do with the review today is just give you a kickstart. We're going to go through the basics. So you've seen the basics. You'll see some things. Oh, that's easy. Oh, that one's kind of hard. I might need to practice that one. Just kind of, and then when you go through on your own, through chapter 0 and chapter 1, you can start picking out things that we didn't cover today and practice those. So hopefully this will ease the burden. And the idea of trying to start studying early and not waiting until Sunday night is do yourself a favor. Like there's two selves here. There's Sunday night self, and then there's the self between now and Sunday night. So the person between now and Sunday night, that's who you are right now. Try to get that person to help out as much as they can for the person who you're going to become on Sunday night. So the person in the past can help the version of you in the future. And so if you can do anything you can do to help study, to help your future self out, that will be really good. And so that's kind of what we're going to do today. We're going to work on that. If you do save it all for Sunday night, I mean, I made it work. I'm sure you can make it work too. I'm just saying you can just make things easier. But it's pretty common. People will save it for the night before, study, and they'll do well on the test. Again, it's just a recommendation to make things a little easier. So what I would say, definitely practice problems that you find are difficult or you don't remember, or you just want to make sure you're good at them. On the test, do the easier problems first, save the harder problems for last. And if you can, if you can, start studying early, go ahead. So that's sort of my introduction to the test. Now there'll be some kind of a proctoring system. What I'll probably do is I'll have everybody proctor the test, but with their cameras on, and I'll be just checking on everyone randomly, just in case you have a intellectually gifted space dog or something like that, or some robot that's helping you do the math. They shouldn't be doing that. I'll be checking on everyone's camera just to see, are you doing it on your own, that sort of thing. So we can try to mimic classroom conditions as best as we can. I'll send out a message about more about that later. So let's get started. So what I'm going to do, I'm just going to go through some what I think are key problems. A few areas that need some work. Again, this is not exhaustive. I'm not going to cover anything at all. There's going to be certainly problems I'm not going to get to today that could be on the test. So that's where you're going to need to come in and look over the old homeworks. That's a good thing to do to see what's going to be helpful. But let's get started. So first off, so prime factorization. Come up with the prime factorization of 210. I'll give you 30 seconds. And I'm not going anywhere very far. If you need to get my attention, have a question, just holler. I'll be here. All right. Now, I'm going to do this a certain way. You might do it a different way. But I'm going to go this way. 21 times 10 is 210. So I'm breaking everything down into prime numbers. And so these are the prime numbers. So the prime factorization of 210 now, you might have a different sort of situation that involves exponents. And let me show you. So we might need the prime factorization of 24. So this is prime, and this is prime. So these are the prime numbers. So we have 2 times 2 times 2 times 3. But the way we write this, especially for x, y, z, this is 2 to the third times 3. So any questions about that? So to continue with practicing, let me give you 30 seconds to reduce that.
I can't see it. Your board's up too high.
Is it too high? Let me see. Oh, let's see. Is that better?
Yes.
All right. Awesome. Now, again, there's different ways of doing this. One way is we might recognize that we can divide top and bottom by 6. And that'll give us 6 over 10. But then we might also recognize we can divide top and bottom by 2. And so this will give us 3/5. So that's one way of doing this. There's another way you could reduce it, though. "36 If you factor 36 into prime numbers, and you do the same for 60, you factor that into prime numbers. Well, what you would get is we could cancel 1 for 1. And you'll get 3/5. So that's the other way you could reduce fractions. Now, something about reducing fractions I do want to mention. Let's say you have 5/25. Now, you might recognize that you can divide top and bottom by 5. And that works perfectly fine. Now let's try it the factorization way. Now you might recognize that 25 is 5 times 5. So we can cancel 1 for 1. And whenever we cancel everything in the top or everything in the bottom, we have to insert a 1. And so this will be our answer, same as before. So any questions about that? So if you have something like this, though, again, we can factor 9 into 3 times 3. We'll cancel 1 for 1. And since we canceled everything in the bottom, we've got to put in a 1. Now, what's important for x, y, z is you have a number over a 1. Well, 1 goes in the 3, and remember, this is a division. 3 divided by 1 is equal to 3. So the answer we want to put in for x, y, z, it's just going to be 3. So that's something to keep in mind. So let's do this. So let me give you about a minute or two to work on these. And again, if any questions, let me know. So I might be going a little fast, and that's just because of the sake of time. So I'm just going to kind of just go through these. But again, if there's something here that's kind of stumping you, take some time this weekend to practice those problems. And again, if any questions about certain problems, let me know. So with multiplication, we multiply across. So we get 6 over 35. We always want to check our answers to see if they reduce. This one won't reduce. So this one we do our KFC. Keep the first fraction, flip the second fraction, change division to multiplication. And again, we just multiply across. We'll get 7 12s. Now with fractions, we can only subtract and add when they have the same denominator or the same bottom number. So since these are the same, we keep that denominator. We subtract the numerators. And we get 1/7. For this same thing, we're going to keep the denominator. We add only the numerators. And so that gives us 7/9. Questions about that? So let's say we have something like this. So how do we deal with something like this? There's a couple ways you're going to do it. I'm going to give you about a minute to work on that. And again, I'm not going anywhere far, so if you have a question, let me know. Now, the thing with problems like this, we can't add fractions unless they have the same denominators. So we have to turn 12 and turn 10 into the same number. Now, it turns out, if you multiply 12 by 5, you'll get 60. If you multiply 10 by 6, you'll also get 60. So we just need to multiply 12 by 5. But, and this is ever so important with fractions, what we do to the bottom, we have to do to the top. And when we turn these numbers, say 12 and 10 into 60, we typically only use multiplication or division. We can't use addition or subtraction. I'm already going to get my pen cap. So multiply 10 by 6, what we do to the bottom, we have to do to the top. So we get 25 over 60 plus 6 over 60. Now we have the same denominators we can add. So we have 60 as a denominator, 25 plus 6, or 31 over 60. And again, we want to make sure that we don't have to reduce anything. Now, we don't have to in this case, because 31 is a prime number. It doesn't break down any further. So that's one way of doing this. The other method is what we call the LCD method. To use this method, we're going to break 12 and 10 down into their prime factorizations. Now for 12, it's 2 times 2 times 3. And I didn't call that 2 squared. For this, we don't need to do that. If we wanted to give x, y, z the prime factorization of 12, we would have to do 2 squared times 3. But in this situation, that's just going to get in the way. Now this one is just 2 times 5. So the technique of LCD is we want to make these lists of numbers to look the same. Now the order doesn't matter in this case, but we want them to have the same kinds and frequency of those kinds of numbers. So since this one has 2 2s, this one will need 2 2s. It has 1 2, and there's the second 2. So 2 2s, 2 2s, we're good. This one has a 3, this one's going to need a 3. So 2 2s, 2 2s, a 3, and a 3. But this one has a 5, this one's missing a 5, so we need to add one in, or multiply one in, I should say. So now let's recap. 2s, 2s, a 3 and a 3, 5 and a 5. They're now the same. So having made these changes, what number is represented by these 2 lists of multiplications? Well, it turns out that this equals 60. And of course, this one will be 60 as well. It'll be the same. So to turn 12 into the 60, we needed to multiply by 5. To turn 10 into 60, we need to multiply by 2 and by 3, which is the same as 10 times 6. And so we end up getting the same procedure as we had before. So multiply top and bottom by 5 to get 60, in the bottom. And then for this one, we'll multiply top and bottom by 6. We'll just do the exact same thing we did before. So that's how you set up using a lowest common denominator. So any questions about that? All right. Let me give you about 30 seconds to name that number. So first thing, we're going to name these two, but we're going to remember what this is called. This is and. So you have 7 and 26. But we're not quite done. We start off with a 7 and 26. But then we need to attach the place value name of the rightmost digit behind the decimal. So we do have digits behind the decimal, and the rightmost one is tenths, hundredths. This is in the hundredths place. That's the place value. So our answer (7 and 26 hundredths). So something that, let me do something that we didn't do an example in class like this. But let's do some now. MN, mixed number. So let's suppose we need to convert this to a mixed number. So we're going to rewrite it like this. So we're going to break up the whole number and the decimal. And what we're going to note is that for the digits behind the decimal point, the rightmost digit is in the hundredths place. The last thing we need to do, we need to reduce 3600. Now, you might notice that 36 and 100 is divisible by 4. I mean, you can reduce it how you want. I'm going to do it this way. And the definition of a mixed number, it's just the whole number plus the fraction, but we write it like this. And so that's going to be our answer. 405 and 9/25. Let me do another one. So let's convert this to a mixed number. We'll break it up as a sum as the whole number and the decimal. And then we'll note that this is the 10th place. So this will become 3 with a 7 over a 10. Or 3 and 7 tenths. Questions about that? Let me do another one. So let's say we want to convert this to a mixed number. We're going to make the note that this is in the thousands place. Tenths, hundreds, thousands. So what that means is we can rewrite this as 4 over 1,000. And we can reduce it. Four and 1,000 are both divisible by 4. So we get a final answer is 8 and 1/250. Questions about that? Let me give you about 30 seconds. All right. So the thing with the adding is you want to line up the decimals. That 1.3, 4.21, and 3.812. Now the key thing though, we've got some gaps. So let's fill in those gaps with zeros. And now we add through the columns. 0, 0, and 2. 0, 1 plus 1. 2 plus 3 plus 8, that's 6 plus 8 is 14. We want to make sure we drop down our decimal. So 3 plus 2 plus 8 is 14. Carry the 1. We'll get 9. And that's going to be our answer. Let me give you another one. Give you about a minute to do that one. 30 seconds. So again, what you want to do, line up your decimals. So we need to borrow. We can't subtract 5 from 3. So we're going to try to borrow from 0, but there's nothing to borrow. Try to borrow from our next neighbor, but there's nothing there. But finally, we can borrow from 8. We'll borrow 1. So now we can do our subtractions. We got to do one more thing. Since we had to skip over zeros, every time we skip over zeros, we make them into 9s. So we borrowed our 1. We had to skip over some zeros to get to this digit here. So we make those into 9s. Now we can subtract. 13 minus 5 is 8. 9 minus 2, 7. 9 minus 1 is 8. Bring down the decimal point. 7 minus 4 is 3. And then that's going to be your answer. I'll give you 30 seconds. So, I want to change this one up a little bit. Pardon me for a second. All right, try that one for 30 seconds. Sorry about that. Try that one. So with multiplication, we don't line up decimal points. we line up the digits furthest behind the decimal. Now, once we've done that, we do long multiplication. 1 times 2 is 2. 1 times 7 is 7. 1 times 3 is 3. Put in 0. 4 times 2 is 8. 4 times 7 is 28. Carry the 2. 4 times 3 is 12. Plus 2 is 14. Carry the 1. 12. Carry the 1. 5. Now I got to place our decimal point. We want to notice there's 3 spaces behind the decimal point. That means our answer, we're going to move 3 spaces to get this. And that's going to be our answer. So any questions about that? All right. So let me give you about 30 seconds to do that. So the division on here might be a bit tricky, but the key thing we want to start out with, we want to make this into a whole number first. And if we move this 1 space over, then we move this decimal over 1 space. So we always move this decimal over by the amount of moves that we made over here. So this is our new problem. Now we can't divide 45 into 2. We can't divide 45 into 29, but we can divide it into 229, at least to an extent. So let's see here. 292 divided by 45. It's 6.4888888, so on. So 45 goes into 292 at least 6 times, or at most 6 times, I should say. So 6 times 45? 27. So you get 22. Bring down the 5. And it turns out 225 divided by 45, that's an even 5. That means we get a remainder of 0. Don't need to bring down any other zeros here to continue dividing. So that, 6 5/10, that's our answer. Questions about that? So let's see. So let me give you about a minute to do this one. Convert 28% to a decimal and convert it to a fraction. So first off to a decimal. Well, to convert a percent to a decimal, we always move the decimal point in the percent 2 spaces to the left. So the 1, 2. This will give us 28 hundredths. Now this is true regardless of the kind of percent you're working with. So let's say we have something like this. To make this into a decimal, we'll go 1, 2. So we'll get very small number. So that's what this would be. 3 thousandths of a percent is actually 3 hundred thousandths. Tenths, hundreds, thousandths, 10 thousandths, 100 thousandths. If you have something like this, again, to convert it into a decimal, we'll move our decimal point 2 spots to the left. To get 7. So questions about that? There is a situation when we move the decimal to the right, but we'll get to that in a little bit. So that's decimal form. What about the fraction form of a percent? Well, recall that a percent is just a fraction with a denominator of 100. And again, we want to reduce. And you might notice that you can divide 28 and 100 by 4. And this will give us 7/25. Questions about that? So let's say we're going from decimal to percent. Well, what we do here is we move the decimal 2 spots to the right. In other words, the other direction. We get 35%. We could have something like this. Again, we move the decimal point 2 spots to the left. we get 7/1000ths of a percent. Or if we have something like this, we'd move the decimal 2 spots over to the right. I mean the right, not the left, to the right. Same thing here, we move 2 spots to the right, not the left. And so we'll get 300%. So to go decimal to percent, we go 2 spots to the right, 2 spots to the right, 2 spots to the right. Now let's say we're going fraction to percent. Well, the first thing we do is long division. Now we can't divide 4 into 3, but we could divide it into 30. And don't forget to bring up your decimal point. So 4 goes into 30 at most 7 times. 7 times 4 is 28. Subtract is 2. Again, we're treating this as 30, not 3.0. Now we've got a remainder, so we can tack on a 0 here. Bring down the 0. Then 4 goes into 20 exactly 5 times. 5 times 4 is 20. Subtract 0. So what we've done, we've now taken our fraction, we've made it into a decimal. And then to convert this decimal into a percent, we just move the decimal 2 spots to the right to get 75%. Questions about that? So there's a situation that came up in this section with mixed numbers. And my recommendation is to convert mixed numbers to improper fractions. So let's say we have something like this. 3.25% to a fraction. Yikes. Well, what we want to do here, let's convert this into an improper fraction. So the way we do that is we keep the denominator, multiply the whole number in the denominator, then we add the numerator. So this will give us 13/4%. So let's make this into an improper fraction. Next, we want to remember what percent means. It means denominator of 100. So whatever percent we have, we're going to give it a denominator of 100. Whatever this whole thing will get a denominator of 100. Now, what this means, all fractions mean division. So this is 13/4 divided by 100. Now, of course, any whole number, we can write it over 1. Because 100 divided by 1 is still going to be 100. Now we do our KFC. Keep the first fraction, flip the second fraction, change this to multiplication. We get 13/400. So what that says is 3 1/4% as a fraction is 13/400. questions about that?
Are we going to be able to use these notes during the test?
I need to talk to the department head. We usually, in the past, we've let you use some kind of a cheat sheet of sorts, or a formula sheet, or note sheet. Let me double check with the department that they're still doing that, but I'll let you know as soon as I can.
Okay.
Awesome. So 0.6, last section of this chapter. Then we'll take a break and we'll finish. We'll do chapter 1 in lab. We'll talk about exponents. So if we have 3 to the 4th, well, this means 3 times 3 times 3 times 3. We have 4 3s. We multiply them all together. Well, 3 times 3 is 9. This is also 9. There's a little multiplication here. And so 9 times 9 is 81. And so that's our answer. And I want to be careful with exponents. But let me show you, we can apply them pretty much everywhere. Like, let's say we have 1/3 squared. Well, this would be 1/3 times 1/3. If we multiply across, we'll get 9. Likewise, if we have 3/10 squared, this will be 3/10 times 3/10. So let me break this down in multiplication. Again, I'm lining up my farthest digits. By coincidence, my decimal points are lining up. That's only coincidence. 3 times 3 is 9. 3 times 0 is 0. I have a total of 2 spaces behind the decimal. So for my answer, I'm going to move my decimal 2 spaces. Put in a little placeholder 0 there for style, if you will. But it's a placeholder. And that's going to be my final answer. Now, I mentioned we need to be careful with these. And where we need to be careful is with negative numbers. So -2 squared. -2 times -2. We take 2 negative 2's, we multiply them together. Negative times negative will be positive. We have +4. Now, where we need to be careful is this. This has a special meaning. This is -1 times 2 squared. Now, if we follow our order of operations, which we're going to get into in just a second, we take care of exponents first and then multiplication. So 2 squared is 4, and we're going to get -4. And that's going to be our final answer. So this and this, you'll get very different answers. So just keep an eye out for those. So when 1 is an exponent, nothing changes. 5 to the 1 is 5. Negative 3 to the 1 is negative 3. 1/2 to the 1 is 1/2. Now, if you had something like this, though, you'll get negative 2 back, but that's kind of by coincidence. Another one, 0 to the 1. 1. Again, nothing changes. It's 0. Now, this is where we have to be careful. Five to the 0 is 1. Negative 3 to the 0 is 1. Any number to the first power, or to the 0 power, is 1, except for 0. 0 to the 0 is undefined. Now, what happens if you did something like this, though? Well, again, this will be negative 1 times 2 to the 0. We've got to follow our order of operations. Excuse me, take care of exponents first. So we get negative 1 times 1, or negative 1. So you got to be careful when there aren't parentheses there. So those are the things that came up with exponents. Let's look at order of operations. Let me give you about a minute to do this. All right. So you want to follow order of operations. That's PEMDAS. Parentheses, exponents, multiplication and division. They're on the same. Those two are on the same level. You just do them as you see them from left to right. And once those are all out of the way, addition, subtraction, you do those together, and you do them as you see them from left to right. So first off, parentheses. Parentheses will always come first. So the innermost parentheses is this. Now we got to work inside these brackets. We got to choose. This is multiplication. This is subtraction. Multiplication and division come before addition and subtraction. Now we can finish up what's inside the brackets. 8 minus 6 will be 2. And now we've got to choose multiplication or addition. Well, again, multiplication and division are always before addition and subtraction. So we do the multiplication first. Then finally we add, and we get 12. And that's our final answer. One more, and then that's it for chapter 0. And then we'll break for lab. We'll take a break and then we'll go to lab. And again, I'll give you a minute to do this one. All right. So the key with this is a division. And we're going to do division, in this case, last. You can think of this as having parentheses around the top and then around the bottom. So we'll do what's in these sort of invisible parentheses first, and what's in between these invisible parentheses first. And then we do the division. So up here, we have addition or multiplication. We'll do multiplication first. Then we can do adding and subtracting. 20 plus 12 is 32. 11 minus 7 is 4. Finally, this is division. That's going to come out to 8. Questions about that? So again, we haven't covered everything in this section. Like I didn't get to rounding, or we skipped over rounding. And definitely, if you want to review that, of course. There's some other problems that I didn't cover, like something, for example, like this. Like which fraction is larger? And we can't judge that until they have common denominators. You might be able to. You could probably eyeball it. But we could turn 5 into 30 by multiplying by 6. But what we did to the bottom, we got to do to the top. And again, I'm limited to multiplication and division, no subtraction or addition for modifying bottom and top, at least in this way. At least when we're trying to find common denominators. For common denominators, you're limited to multiplying or dividing. So now we can take a look. A 7 out of 30 or an 18 out of 30. Well, that's a better score than this. So that means 3/5 is bigger than 7/30. So there's questions like this out there. So again, this is just sort of a review, gives you sort of a basis to build off of. Go through chapter 0, look for things that don't quite make sense, practice problems. Practice problems you think that you can do, but you get stressed out, you wouldn't be able to do under stressful conditions. But practice, practice, practice. So that's it. So if you have any questions, let me know. I'm going to stop recording for this session, and then we'll take a quick break, and then we'll start the lab at 2:30.